Hello, grade 6 math students. This is chapter 4.2, part 1, equivalent ratios. There are 3 new skills in this chapter. We will learn to write equivalent ratios. We'll learn to write ratios in simplest form. And finally, we'll compare ratios. Let's get started. Equivalent ratios show the same comparisons of numbers and quantities. Let's begin with a ratio problem that involves Linus's collection of marbles. Linus has 8 red marbles and 12 blue marbles in his collection. The ratio of the number of red marbles to the number of blue marbles is 8 to 12. Now let's say that Linus is going to group 2 marbles of the same color into each group, like this. Now we have 4 groups of red marbles and 6 groups of blue marbles. So now the ratio of the number of groups of red marbles to the number of groups of blue marbles is 4 to 6. Next, Linus is going to group 4 marbles of the same color into each group, like this. Now, there are 2 groups of red marbles and 3 groups of blue marbles. The ratio of the number of groups of red marbles to the number of groups of blue marbles is 2 to 3. Notice that Linus is not changing the number of red marbles or the number of blue marbles ever. He's only regrouping the marbles. So 8 red marbles becomes 4 groups of 2 or 2 groups of 4, but there are still 8 red marbles. And the 12 blue marbles become 6 groups of 2 or 3 groups of 4, but there are still 12 blue marbles. So these 3 ratios, 8 to 12, 4 to 6, and 2 to 3, are equivalent ratios. They represent the same quantities, simply stated in a different way. Let's try a set of 4 problems in which we'll work through creating equivalent ratios using a set of pencils and a set of erasers. In number 1, simply give the ratio of number of pencils to number of erasers as they appear. In number 2, write the ratio of groups of pencils to groups of erasers. Press pause to finish these 2, and when you come back, we'll complete parts 3 and 4. Now let's look at number 3 and use the group of pencils and the group of erasers to create another equivalent ratio. In number 4, you're simply going to articulate or write out what you've been doing in steps 1, 2, and 3. You're going to show how you took 10 pencils and 20 erasers and divided them into groups of 2, and then how you took that same quantity and divided them into groups of 10. Then you'll write the 3 equivalent ratios you have created. Okay, press pause, complete this step, and when you come back, we'll learn how to use greatest common factors to write ratios in simplest forms. See you in a minute. Now let's learn to use the greatest common factor to write ratios in their simplest forms. You can write a ratio in simplest form by dividing the terms by their greatest common factor. Essentially, it's just like reducing a fraction, okay? So we want to express the ratio 50 to 20 in its simplest form. The greatest common factor of each side will be 10. So we're going to divide 20 by 10, and we're going to divide 50 by 10 to give us our new answer, our new ratio, 5 to 2. Let's try another. Let's express 8 centimeters to 3 meters in simplest form. Well, the first thing we have to do is to get our 2 quantities to be in the same units. So 8 centimeters to 300 centimeters, because there are 100 centimeters in each meter. 3 times 100 gives us 300 centimeters. So 8 to 300, do they have a common factor? They sure do. Each can be divided by 4 to give us our new equivalent ratio, which will be 2 to 75. See, just like reducing fractions. Now reduce these two ratios to their simplest form on your own. Record your answers in your notebook, and we'll move on as soon as you're finished. Now let's use simplest form to reduce ratios and determine if they're equivalent. We have a pair of ratios here, P to Q and R to S. P to Q is equal to 1 to 2, and R to S is equal to 2 to 4. Is P to Q in its simplest form? Yes, it is. 1 to 2 is already in its simplest form. Is R to S in its simplest form? No. Each term can be divided by 2, giving us a new equivalent ratio of 1 to 2. As the ratios in their simplest forms are identical, then these two ratios are equivalent. Let's assess another pair. Are the ratios 3 to 4 and 6 to 9 equivalent? First, let's make sure that each ratio is expressed in its simplest form. 3 to 4 is already in its simplest form. Neither number can be reduced by a common factor. 6 and 9, however, do share a greatest common factor, and that number is 3. So let's divide each side by 3 and get our new ratio, which will be 2 to 3. Well, 3 to 4 does not equal 2 to 3. So 3 to 4 and 6 to 9 are not equivalent ratios. Let's work through a final one together before you try some on your own. Are the ratios 1 to 4 and 12 to 3 equivalent? Well, 1 to 4 is already in its simplest form. 12 to 3, each side can be reduced by 3, divided by 3, giving us a ratio of 4 to 1. Is 1 to 4 equivalent to 4 to 1? No, it is not. They may share the same terms, but the order of the terms is important. 1 to 4 is not the same thing as 4 to 1. Remember, if we were to write these in fraction form, they would look like this. When you do that, it's really easy to see that they are not the same quantity. So 1 to 4 and 12 to 3 are not equivalent ratios. We finish out part 1 with 4 final problems. For each pair of ratios, determine if they are equivalent or not. First, make sure you've written each ratio in its simplest form in your homework notebook, and then tell me if those ratios are equivalent or not equivalent. Tomorrow we'll find more equivalent ratios using different techniques. See you then.